Welcome to the 2024 WidgetKit Masterclass. This video is a compilation of all of my WidgetKit tutorials, going from the very basics to all of the advanced stuff added in iOS 17 and iOS 16. This compilation includes scheduling widget timelines, displaying views in your widgets, doing API calls in your widget timelines, different size classes, Lockscreen Widgets. It also introduces the concept of an AppIntent and how it can be used to create interactive widgets, but also configurable widgets. This tutorial or this masterclass also includes using CoreData and UserDefaults to share data between your main app and your widget extension, and there is much more to learn in here as well. While the first few lessons are already a bit older as they portray the basics of using WidgetKit and none of that has changed over the years, the other stuff is brand new, showing you all of the new features in iOS 16 and 17. I hope you enjoy it. And now let's get started with this masterclass.
Hey, this is Flo, and this is the introduction to the new video series that I'm launching right now. And in this series, we will actually look at WidgetKit. I will teach you about the very basics, intermediate stuff, and then how you can actually implement and use it in practice. And we will do that by building on top of the stocks app that we made in last month's 30-day app challenge from Code with Chris. So I'm using that as a base. So if you want to get a head start, then I would suggest you to watch that series first. I think it's 8 videos, so it shouldn't take too long. And then in this series we will create a widget. We will add a widget extension, set up a custom configuration. I will tell you about the structure of all of the pre-generated code, because Xcode actually generates a lot of code for you already when adding a widget extension to your project. We will then separate all of that code, make it a bit cleaner, and finally work on our own custom widget, which will, for example, also use some files that are already in the app target, and we will add them to the widget extension as well. This is just a very quick overview of all of the topics that we're going to cover in this series. If you are excited for the series, then please hit a thumbs up, subscribe to the channel, and I will see you in the next episode. Hey, this is Flo, and welcome to the first real episode of our WidgetKit series. As I've said in episode 0, we will start by taking the stocks app that we have developed over the course of the last few videos in the 30-day app challenge from Code with Chris for last month. And we will actually add a widget extension. So let's just get into it. So to add an extension, just go to File, New, Target, and then just search for widget. And then you can already see the widget extension here. Click Next. You should give it a name. I'll just call it Stocks Widget, like this. All of this should be fine. Because we will use configuration intents, you should definitely check the include configuration intent box here, because we're going to use that. Then hit finish. You can activate the scheme. Let me quickly explain to you what that did. So basically now you have 2 schemes to build your project. One scheme to actually build the iPhone app, and then one scheme to just build the widget extension, which is very handy because this can be used to, for example, automatically install the widget on the simulator, and you don't have to do anything and you can just test it really quickly. Okay, so we're selecting that widget extension. Okay, now if you notice, we have this stocks app folder here. Let me collapse that. And now there's actually a stocks widget folder, which I can open up, and there is a couple of files in here. So first of all, there's an info plist, like always. There is an asset catalog, which you can use separately from the asset catalog of the app. We have an intent definition. So this is basically the configuration intent that I just told you to check. And then we have the code, which is actually all inside of one single file here. Okay, so as you can see, there's an intent timeline provider, there's a timeline entry, then there's a view here, so stuff like this should be familiar to you. Then there's the actual entry point to the widget extension, which is a struct conforming to widget, which is very similar to the struct conforming to app in your app target. which also has a body similar to views, but it's not of a view, it's actually a widget configuration. We'll go into this in the next episode. And then of course at the bottom we also have a preview provider, which is very handy because that way you don't have to actually run the simulator. So let me actually open up the canvas in this file and hit resume, and now Xcode will actually build and run this widget here. Let's wait for a second. Okay, and as you can see, the preview works. We have a system small widget here. We'll go into detail about what all the size classes are in a later video. But as you can see, this is just a dummy widget that was generated by Xcode, so we don't have to write all of the boilerplate code ourselves. Okay, that's already it for the first episode. I just wanted to show you how to add the extension, and then in the next one I will show you how to set up a configuration intent to let the user configure a widget. And for example, in our case, we will let the user enter a stock symbol like IBM or AAPL for Apple, and then the widget will actually fetch the stock data for that symbol. Okay, if you liked the video, please make sure to hit the like button, subscribe to the channel to not miss the next episodes, and I'll see you in the next one. Bye. Hey, this is Flo and welcome back to the next part of the WidgetKit series. In the first part, we actually just added the extension to our project, and I went over all of the generated code very briefly. In this part, I will tell you a bit more detail about the generated code, about the structure of a widget, how you need to implement it, and then we will actually look at how to add a configuration intent or how to edit a configuration intent to enable the user to enter a stock symbol like IBM or AAPL, and then change the widget's content based on that. So if you like the series so far, please make sure to hit the like button, subscribe to the channel, and leave a comment down below what you wish to be covered in a future video series or just a single video. Okay, so let's get into this. And actually, to explain to you how the widget works, I will scroll down all the way until we find our main entry point to the widget. And I've actually told you about this already. So basically the starting point is very similar to our stocks app starting point in the main iOS app. So there's a struct conforming to app, which has a body, and in that our UI is rendered. This is very similar in a widget. So we have a struct conforming to widget because we're not dealing with an actual app here. And then it has a body, which renders our UI and our configuration and so on. Now, as you can see, there is a widget configuration in here, and we are using an intent configuration. There's also a static configuration, but intent configurations allow the user to change some parameters like the stock symbol. In this intent configuration, we pass basically the name or the identifier of the widget, which in this case is just stocks widget. Then we also pass the intent that we actually want the user to be able to edit or that we want to have inside of our view, which is the configuration intent. So this is just pre-generated by Xcode when we selected include configuration intent in our target. Then we have a provider, which is the timeline provider up here. So this basically is needed because widgets work on a timeline similar to watch complications, which enables the widget to be refreshed at set intervals and to reload basically. So you need some sort of timeline here. And then this is very Swift UI style. So you get an entry in here in a trailing closure, and then you just have your actual view. So this is basically this up here, just Swift UI views. And for that view, you usually pass your timeline entry, which in this case just contains a date. This is needed, and then a configuration, which is the configuration intent. Then this intent configuration can also be customized. So for example, you can give your widget a name. This is helpful if you want to add several different widgets to an app. So then you could name one, for example, a stocks widget, and one a statistics widget, and one a whatever widget. So this enables you to have different names for different kinds of widgets. Then you can also add descriptions, and then you can also add the supported families. So as you know, there are 3 kinds of widgets right now. There is the system small, which you can see on the right hand side here. Then there's the system medium, which is basically twice the width of this one. And then there's the system large, which is basically 4 times as big as this widget here. And now here in the supported families, you can actually just pass an array of all of the different supported families that you want. In this case, let's just add system medium in here. Let's resume the preview, and now it should show us a medium-sized widget. Actually, it doesn't, because our preview context says system small, so we should change that to system medium. And now you can see the preview shows us a medium-sized widget. So what this supported families up here does is it toggles which families the user can actually select. So in code, we can force a different size, but the user can now only select a medium-sized widget. Let me show that to you on the simulator. So I'll just run the extension scheme, which we selected up here. Okay, as you can see, the widget got automatically installed because we selected the widget extension scheme in Xcode. And now if I edit the home screen, tap the plus icon, then there should be the stocks app right here. We can tap on that, and as you can see, now the user can't select any other widget except for the medium-sized one because we specified it here in the supported families. Then our description and configuration display name are also displayed right here. And now the last thing, we can tap and hold the widget, and right now nothing happens. And now the last thing, we can tap and hold the widget, and now, And the last thing, we can tap and hold the widget and select Edit Widget right here, which will then open up the configuration. Right now there is nothing to configure because we haven't added any parameters, but let's actually look at that right now. To change the configuration parameters, we need to go into our intent definition, which is called stocksWidget.intentDefinition. And then you can see our configuration intent here. You can change the name. You definitely need to check that it is eligible for widgets because otherwise we can't use it in our widget. And now the most important part is the parameter list down here. So let's just add a parameter. Let's call it symbol because that's what we actually want the user to enter. We want them to enter, for example, IBM, AAPL, TSLA, whatever, some stock symbol. And now on the right hand side here, you can change the display name. So this is the internal name of the generated class member. And then on the right hand side here is the displayed name for the user when they edit the widget. You can change the data type. We will actually use string because that's what we need. You could enable it to be an array. Now there's different other options here. We don't really need them. We could, for example, provide a default value of IBM. We can also change the keyboard settings here. So capitalizations, we could actually set it to all characters because that's how stock symbols work, right? They're all capitalized. And then there's a couple of other settings, but I don't think that they're really important for the basic understanding. Okay, so now this symbol parameter is part of our configuration intent. Now if we run the target again, okay, we actually also need to add a zero dialog here. So let's just put in some test value. Let's build again. Now it should work. We don't really care about the zero dialog right now. Now the build works. Let's actually run it on the simulator now. Okay, and now if we edit the widget, we have the symbol parameter here, which we can enter some text into. It gets auto-capitalized. And then this is actually sent to the widget. What this now allows us to do is, for example, scroll down here into our stocks widget entry view, so our actual Swift UI view that is displayed inside of the widget. And let's embed this text, for example, in a VStack. And below the time, we could add a text of our entry.configuration.symbol. This is now generated for us. This is optional, so we can optional chain it with, for example, no value, like this. Now if we run the widget again, let's see what happens. Okay, and as you can see, now the symbol value of our configuration intent that the user actually entered when they edited the widget is now displayed inside of the view. Okay, so that's it for the configuration intents for this episode. If you enjoyed the video, please hit the thumbs up button, subscribe to the channel, and stay tuned for the next video. Bye! Hey, this is Flo and welcome back to the third part of our WidgetKit series, where we take the Stocks app from the 30-day Stocks app challenge from Code with Chris for the month of May, and we add a widget to it, and I explain to you all the details about configuration intents, timelines, the general setup of widgets, and so on. Until now, we have only altered this a little bit, but what we have actually done is we have worked on our configuration intent and we added the symbol parameter, which represents a stock symbol, and we have already displayed the value in a text view here. Today we are going to actually work on the widget itself, so the UI. But before we do that, I want to actually separate all of this code, because right now there's 1, 2, 3, 4 different structs in one file. I personally just really don't like that. So what I will do is create separate files for all of these structs. So let's start at the top with the timeline provider. Let's copy this whole struct and let's delete it from in here, and then just create a new file. Let's just call it timeline provider, like this. Now in the target section down below, make sure it is not in the actual Stocks app, but it is in the Stocks widget extension. Hit create. And then in here we definitely need WidgetKit. I think we also need intents, and then we can just paste in the provider here. Okay, next up I want to extract the entry, the timeline entry. So let's remove that as well. Create a new file. Let's call it timeline entry. Once again, make sure that the correct target is selected. Hit create. Import WidgetKit. Paste it in there. I don't think we need intents in here, so that should be fine. And then the last thing that I want to extract is our actual widget view. So let's copy it, remove it as well, create a last Swift file. Let's call it widget view, or let's actually call it stocks widget view. Make sure the correct target is selected. Hit create. And here we need Swift UI. We also need WidgetKit, I think. Let's paste it, and that should be fine. Okay, so now that we have separated all the code, it will be a lot easier to navigate. Let's hit Command B to build the project. Okay, it failed. Why did it fail? Because now that we have separated it into different files, we actually need to specify that this is a simple entry here, and now this should work as well. I'm not quite sure why this is the case, because you can leave the generic entry protocol in here. I think it's a protocol in another class. Don't quote me on that. If you have it all in one file, but if you separate the files, then that doesn't work anymore. If you know the solution, maybe you can just write a comment down below. Okay, so now that we have everything separated, I want to show you how to use code from the iOS app inside of the widget extension. And we have basically already covered this when we created the new files. So if we open the panel here on the right, click on the file inspector, and then in the target membership, we need to make sure that any file that we want to use in the widget extension is actually a member of the widget extension target. So for example, in this widget, I want to use the line chart that we created. I also need the network calls, so the everything that we have in the content view model. And obviously we also need our stock data model and the API key. So what we are now going to do is, for example, go into the line chart, go into the inspector on the right and select the widget extension as another target. Then we can close this again. And now we can actually use the line chart in the widget extension. We will also do the same for the stock data, which is our data model, added to the extension. Now we also have the content view model. The thing is that we have no service. So we would have to extract this into a service. Let me do this real quick. This isn't really important for the WidgetKit course itself. So I just show you what I did and get back to you in a second. Okay, so I've actually done a really quick refactoring. I have added a services group and extracted everything from our getStockData function into a static function of a stock service. It is literally copy-paste, so nothing to find here, except that I had to erase it to any publisher, so I could return an any publisher, which makes it just a bit cleaner. If you want to learn more about Combine, then you can just watch my Combine video. But now I have this stock service, so that this is reusable, so I can now add it to the stocks widget extension target, close this file, and as you can see, I just called it in our content view model. So now we can close the content view model as well. Of course, I also added the API key.swift to our target, so we can use it in the stock service. Okay, so right now we are inside of the view. Let's close this right panel here, but I actually want to see the preview, so let's just fix the preview, and now it is also shown when we change files, so let's hit resume. Okay, now that we have the stock service and everything from the app in our widget extension target, you would think that you could, for example, call the service in the view, but that actually doesn't work because views in widgets can't get updated or redrawn. So what you actually need to do is you need to add whatever you want to have computed in your entry and then compute it in the timeline. This might sound a bit weird, but let me show you what I mean by this. Okay, so in the timeline entry, this is basically our data struct. This is basically all of the values that we want to show in the view. So we also want some stock data. So let's add stock data here to our simple entry. Now inside of the timeline, actually let's make the stock data optional, because that makes it easier to use it in the placeholder and in the snapshot. Okay, so now that we have the stock data in our timeline entry, our simple entry, we can go into the timeline provider and actually create a function to actually fetch the data. So let's create a func get or create timeline entry. Okay, this will need a date of type date. It will need a configuration of type configuration intent, and then we will also need the closure here at the end. Let's actually call it completion. So this is what's called with the entry as the content. So let's copy the signature from here. Let's paste it in there. Okay. So now we can use our stock service .get stock data for our configuration.symbol, and since this is optional, we can optional chain it, and if it's nil, let's just use IBM as a placeholder. Then we can subscribe to this. Let's not care about the completion for now. It doesn't really matter at the moment. Let's just care about what happens when we get some stock data in. So let's create an entry. So let entry equals a simple entry with the date that we got, with the configuration that we got, and with the stock data that we just received here. Let's store all of this in a set of any cancelable, and to do that you actually need to change the provider from a struct to a class, because otherwise you can't mutate the cancelable set. So let's say var cancelables is a type of set any cancelable, and let's initialize it to be empty. To be able to use any cancelable, you of course need to import combine here at the top. Now we can store the subscription in our set here. And now this function can be used in the get snapshot. So let's just say create timeline entry for the current date with the given configuration and with the given completion handler here. In the placeholder, we actually don't care about the stock data. So let's just set that to nil. So let me explain to you why there are three different functions anyways. So the placeholder is, as the name suggests, just a placeholder until the actual widget is loaded. This is, for example, shown when the user adds a widget. Then get snapshot is just basically the current version of the widget. And then get timeline can be used to construct a timeline, for example, to update the widget every hour. So that's something that you could do. For this example, we will just have one entry in the timeline. So what we're going to do is, first of all, we forgot to call the completion handler down here. So let's call the completion handler on the simple entry that we just created. And now in here, the timeline will just consist of one simple entry. So we should create another function. This will be very similar. You could refactor this, of course. So let's just call this one create timeline. And instead of returning just a simple entry to the closure, we want to return a timeline with the generic type simple entry. And now we can't do it like this, so we need to create a timeline. So let timeline equals a timeline, and we will just have our one entry in there. And now there is a reload policy, and since we only have one entry, we actually don't need to reload this. So let's just say never. Then we can call the completion block with the timeline. And this now enables us to scrap all of this code in the get timeline function and just call our create timeline for the current date with the given configuration from the timeline call and with the given completion handler. Okay, so as I said, in most cases you want up-to-date information in your widget, so you should definitely create several entries in the timeline, put them into an array and pass that array into the timeline here, and then call the completion block with all of these different entries. Just for the sake of simplicity, I'm not going to do that, but it shouldn't be too hard to do that yourself. Let me actually explain the timeline in a bit more detail, because I think I skipped over it a bit too much until now. So what we did is we called the create timeline method in the get timeline method, which is part of the intent timeline provider protocol. Now what the timeline allows you to do is to create an array of entries, each with a date specified. So for example, you could create an entry for right now, which is the current state of the widget. And then you create a second entry in 30 minutes, which would then refresh the widget and show some new information. And then 30 minutes later, another entry, and so on. So you could split up basically the future, so the timeline of your widget. When is this useful? For example, in a calendar app, where you already know what you want to display in, say, 30 or 60 minutes. But as we are dealing with stocks here, we can't predict them. So they are going to change in the future, but we don't know to which value. So we also don't know what to feed into our widget view, so what we need in our simple entry. Because of that, it really makes no sense to already create the entries for the future inside of the timeline. So what we can do instead is, when we initialize the timeline here, we just pass the single entry for right now with the current stock data that we fetched from our stock service. And we can actually provide a policy. And now if I remove this and press the dot again, you can see the three options. So the first option is at end, a policy that specifies that WidgetKit requests a new timeline after the last date in this timeline passes. So once the last entry's date in this timeline is over, then the getTimeline method will get called again and a new timeline is generated. Never, as a time reload policy, specifies that the app prompts WidgetKit when a new timeline is available. And then the third policy, after a date, a policy that specifies a future date for WidgetKit to request a new timeline. So with that, you could, for example, fill your timeline for 8 a.m. to 8 p.m. and you know there won't be any events in the calendar from 8 p.m. to 8 a.m. So you can then just say, okay, you don't need to refresh the timeline at night. Let's just refresh it after 8 a.m. tomorrow. Just an idea where this could be useful. I think in our case, the at-end policy is useful because, as again, WidgetKit requests a new timeline after the last date in a timeline passes. So this could, for example, be useful. So we could put this right here. And then internally, WidgetKit also doesn't request a new timeline over and over and over again, because the operating system iOS actually throttles it and handles the amount of requests you can send. So I think it's rather safe, at least at the moment, to use the at-end policy here. Because once again, after this entry here is over, then a new timeline will get requested. Okay, so now our timeline provider is done. So we can actually go back into our stocks widget view. As you remember, our timeline entry now has the stock data associated with it. So what we can do is we could change this now a bit, and for example, add another text field with the entry .configuration, not .configuration, .stock data. This is optional, so we need to optional chain it. And let's, for example, say the latest close value, which is a computed value, I think, that we created. And since this is optionally chained, we should add a default value here. So let's just say default. Okay. I'm not sure if it will work in the preview, so let's find out. Okay, so it won't work in the preview because the preview actually doesn't call the timeline. So we will have to run this in the simulator. Okay, and as you can see, the widget now displays the current time from the first text view here. It displays the selected symbol from the second text view here, and it displays the latest close value which we fetched via an API in this third text view here. Now, the next thing that should be done is add the line chart that we created in the stocks app and actually put it inside of our view here. So let's do that real quick. For that, what we can do is look into our content view and see how it is implemented here. Okay, so it just takes the close values of the stock data. So actually, I think we can just copy all of this code here. So let's just copy it, go into our stocks widget view, I think we can remove the date now. We can also remove the latest closer values and instead put in the line chart. We don't have a stock, but what we have is our entry.stockData.close values. And if those are nil, then we'll just pass in an empty array. Okay, so let's hit try again here. I think we will see nothing because the array will in fact be empty because the stock data will be nil from the preview. So let's just run this in the simulator right away and then we can see what happens. Okay, and as you can see, now we have our symbol at the top because this is a V-stack with the symbol here, and then we have our line chart below. And now if we tap on the widget, it actually directly opens the app. Okay, great. That's it for this part. I know it's a very lengthy one. I hope you still learned a lot. I hope it was fun. And in the next one, we will handle different size classes and adding different widgets to one app. So see you in the next one. Hey, this is Flo and welcome back to the next part of the WidgetKit course. In this part, I'll just show you how to actually add multiple widgets to your widget extension. And for that, we need to go into our stocks widget file or wherever your widget struct is located. Right now you can see that it is annotated with add main, meaning that this is the main entry point into the widget. And if we want to add multiple widgets, then we need to change this entry point. For that, we will first of all create a new struct, and let's call it stocks widget bundle, and this will actually conform to widget bundle like this. Now a widget bundle also needs a body, so let's add that body of type SomeWidget. Okay, and this body actually needs to be a widget bundle builder like this, annotated like this. Okay, and now inside of the body we need to add all of the widgets that we want to have. So right now only the stocks widget exists, so we can just put the stocks widget in here like this and then move the main annotation from the stocks widget to the widget bundle. Right now nothing actually changes in the app, but if you implement a second widget, which for example could show multiple stocks or some other data, then you can just put it in here next to the stocks widget. I'll just put the stocks widget in here twice, but actually you would want another widget in here. But this is the way how to add multiple different widgets with different timeline providers, different timeline entries, different views, and different functionality into just one widget extension. Okay, that's already it for this very short video. And in the next part, we will look at how to actually create different size classes and then display different content based on the size classes. So see you then. Hey, this is Flo and welcome back to the WidgetKit course. Last time I showed you how to add multiple widgets to one widget extension. And this time I will show you how to add multiple supported families to one widget and then also display different content based on which family is given. Okay, so first of all, you want to move into your widget struct, which in my case is the stocks widget, in the stockswidget.swift file. And in the body here, we have a configuration of our actual widget view, which in this case is called stocks widget entry view, and it is a intent configuration. Just as a reminder, there's also a static configuration, but as we want the user to be able to enter a stock symbol, we need the intent configuration using our configuration intent. Okay, so now to actually support different widget size classes, there is the supported families modifier down here, and in there you just pass an array of all the size classes that you want to support. So for example, we have added system medium, but you could also add system small or system large. So let's add system small. Now to actually see see the new widget in the preview, we could change the preview context family in this preview, or what we could do is copy all of it, create a group in here, paste it back in, and then paste it in another time, but this time with a different family. Now if I rerun the preview, you will notice that we will have two widgets. So at the top we will have the system medium size widget, and at the bottom we will have the system small size widget. Let's actually look at that in the simulator as well. Okay, so as you can see from the previous episodes, we still have the medium-sized widget up here, and we also have the small-sized widget down here. And if we now edit the home screen, tap the plus icon, scroll down to the Stocks app, then you will see the system small size is available, but the system medium size is also available. Okay, now to actually change the widget's content based on the supported size, based on the selected size, one idea would be to create different widgets. One which only supports, for example, system small with its own timeline provider and its own timeline entries, and then another widget only supporting system medium with its own timeline provider and its own timeline entries, and then putting both of these widgets in our widget bundle body. This is one way to do it, but the easier way is to just support both families for our stocks widget, and now go into the stocks widget view. And inside of the stocks widget view, we can actually grab the widget family from the environment. So just say add environment, and then the key path is widget family, and store this in a variable. Let me just call it family. Since you can see that syntax highlighting works, this is actually the correct notation. Let's option click on this, and here you can see the template of the widget, small, medium, or large. And now we can change what is displayed based on the widget family. So in our body, we could now grab all of the VStack, copy it and remove it. Okay, and here we can actually just create a switch statement on the widget family. So let's just say switch over the family. One case would be system small. In here we could, for example, just show some text. Another case would be system medium. Those are the two families that we're actually supporting. Let's for now also just put some text in here. And then in the default case, let's just say not implemented. Okay, so this will work. And now what we can do is in the system medium, just paste our VStack back in. And this way we can actually show different content based on the widget size. Now what you should obviously do is not put the VStack in here, but actually create a different view for it and then just call the view in here. Now all of this works because the body is actually a view builder. Otherwise you wouldn't be able to switch over the family and show different views, but that's a topic for another video. Okay, so what we could now say in here, just for simplicity reasons, let's remove this VStack again, put in a text saying medium size, and in the system small, let's just say small size, and then default should be not implemented. Now we can go back to our stocks widget, resume the preview, and then you will see that the medium sized widget will just say medium size, and the small size widget will just say small size, because those are the views that we return in our switch statement. Now, for example, in the system medium, we could paste the VStack back in, and this will work. Right now, the line chart is not displayed because the configuration intent has no value for the symbol parameter. But if we run this again in the simulator, you will see that the small size now actually shows small size as we have specified in our switch statement, and the medium size widget will actually show our VStack with the symbol and the line chart as we have specified over here. Okay, that's it for this part. I hope that you learned something, and if you did, please make sure to like the video, subscribe to the channel, and I will see you in the next one. Hey, this is Flo and welcome back to the WidgetKit course. In this episode I will show you how to feed the user custom data to choose from when configuring the widget through a configuration intent. Right now our widget has a symbol field which the user can actually enter a string into, and then this string will get passed into the widget. But what we want is for the user to not be able to put in any string, but just one of the different objects that we provide the user with. So for that we will actually go into our intent definition, and for the parameters we will add another parameter, and let's call this custom symbol. Okay. For the type we will say add type, and let's call this one custom symbol, like this. It will have an identifier and a display string. Both of these are required. Okay, let's go back to the configuration, to the custom symbol, make sure the type is set correctly. Good. Now what we need to do is we need to add another extension to our app. So let's say file, new, target. Let's search for intent extension or intents extension. Hit next. Let's just call it stocks app intents. Don't hit include UI extension and select starting point none. The default here is messaging, but we don't need a starting point. Okay, let's hit finish. Activate the scheme. All right. And now you will see on the left hand side here we have the stocks app, we have the stocks widget, and we have the stocks app intents now. We only need the widget and the intents for now. So the first thing that we need to do is add the intent definition to our intent target, like this. Okay, then we can go into the intent handler. Okay, now in this intent handler we need to provide a function that gives the user all of the options to choose from which we want to provide. So for that, Apple actually has a great website. So you need to implement the provide options collection function. So actually what I will do is just copy their implementation and change it to what we need. So we called our custom type custom symbol. So instead of provide character options collection, we will say provide custom symbol options collection for intent configuration intent. That's why we had to add our intent definition to this target. And then the type here will be custom symbol, and all of this can be removed. Okay, we can keep this. Let's actually call the collection symbols instead of characters. And now what we can do is say let symbols of type custom symbol equal, and in here put all of the symbols that we want the user to be able to pick. Okay, obviously you could fetch these from CoreData now or via an API or however you want to provide all of the options. We will do it the most basic way. So let's say we are just gonna add a few custom symbols. We're going to use this simple initializer, give it an identifier and a display name. So let's say we want Apple, and as a display name just say Apple, and let's add another one, custom symbol with the same initializer. Let's do TSLA, and for the display name let's say Tesla. Okay, so there are still 3 quick things that we need to do for this to actually work. So first of all, in our intent definition, we need to make the custom symbol dynamic. So let's check options are provided dynamically here. Then we need to go into the intent handler. First of all, make it a member of the widget extension, and second of all, conform to a protocol called configuration intent handling. Now the first part here is just the name of your intent, and this protocol is actually generated automatically by Xcode. So let's have a look at it. Jump to definition. Here you can see automatically generated, and it just has this one function that we just implemented. Okay, now we can run this in the simulator. Okay, let's hit edit widget. You can see there's still the string symbol that the user can enter, but also now the custom symbol that the user can choose. And you can see this quick search field comes up here, and both of the custom symbols are displayed. Now, obviously, the display name is displayed, so Apple instead of AAPL. Let's just select Apple for now, and you can see it is saved in here. Okay, but how do we actually work with this data in the widget now? This is also pretty easy. Let's take a look at it. Okay, what we could now do is, for example, add another text element here. In here we can say entry.configuration, and then in here we can just quickly access the custom symbol. And in here we could, for example, take the display string, or we could take the identifier, which would make more sense in our case. Since all of this is optionally chained, we need to provide a default value or force unwrapped. Let's say for a default value, no custom symbol selected, just like that. And why do we want the identifier? Well, because in our intent handler, we put the symbol into the identifier and the name of the stock into the display name. So we obviously need the identifier. Okay, let's run this once again in the simulator and see if it works. Okay, and as you can see, the widget updated. It now shows two text labels, and just to make sure that this is actually the custom symbol here, we can edit the widget and select another custom symbol. So Tesla in this case. Go back, it will refresh, and you can see that Tesla is up there. So now you could, for example, use this custom symbol to fetch the data instead of the symbol that we used beforehand. Okay, that's it for this video. I hope you learned something. I think this is quite useful. If you did, then please hit the thumbs up button, subscribe to the channel, and I will see you in the next one. Bye! Hey, this is Flo and welcome back to the WidgetKit course. In this episode, I will show you how to respond to user interactions. So how to notice that the app got called or got opened when the user tapped on the widget. Let me show you the simulator for that. So right here I have our stocks app widget, and when I tap on it, then the app will open. And in this case, as I just implemented a very simple version to show you how it works, it will have a text here with the symbol that was selected in the widget configuration. So the widget shows the stocks data for Apple, and when the app is opened, then this AAPL string is passed into the app, and we could now work with it and, for example, open a detail view or whatever. So that's what the app will look like in the end. For that, there is basically 3 steps. So we will have to construct a URL with which the widget will then open the app. So to actually get the symbol inside of the URL, we will add a computed property to our stock data model. So we will just call it URL, and it will also be of type URL. And you can actually make this optional, because the function that we're going to use will work with optional, but I will make it non-optional for now, because there's actually 2 ways to implement this into the widget. So now we will have to construct a URL here. So I will use a guardlet just to make sure that it's not optional. So guardlet URL equals a URL from a string. We will talk about this string in a second. And if this is not possible, then actually I will throw a fatal error, because the URL should always be able to get constructed. And in here I will just say fail to construct URL. And then in the end, I will just return the URL like this. Okay, so now let's talk about the actual URL. So you can make this whatever you want. But here is a simple idea of how I would implement it, and which will give you actually a lot of customizability. So let's see how it will look like. So first of all, I will put the app name basically as the scheme. So which would be HTTPS in a regular web URL. Then colon // then the name of the route basically, let's call it this. So I will call it symbol, and then we can pass arguments in here. So what I will do is just pass our how's it called, metadata dot symbol. So if we scroll up here a bit, you can see we have a metadata inside of the stock data, which has the symbol of this stock. Okay, and I will just put that into the URL. Why am I structuring it like this? You will see that once we are inside of the app and receiving the actual open URL call, because then this will make a lot more sense, I would think. Okay, second step is go into our stocks widget entry view. So in our widget extension, the view that is actually displayed. So in a past episode, I showed you how to work with different widget families, but we're just focusing on the system medium style for now. And what we can just do is to the outermost container here, so the vstack, we will add the widget URL modifier. And in here we can pass the URL that should be passed to the app when it's opened through the widget. So we can just say our entry dot stock data, this is optional, dot URL, so the computed property that we just created over here in the stock data. And now every time that the app is opened, when the user taps on the widget, this URL will be passed to the app. So as you can see, this takes an optional URL, and that's why it's fine that our stock data is actually optional here. Another way would be to not put the modifier here, but instead wrap everything in a link. So I will just show you how that would work right here. So just use a link with the destination of our entry.stockdata.url. But the issue here now is that this does not work with optionals. So you would have to force unwrap the stock data, which is kind of sketchy, I would say. And then inside of the link, you can put everything that you want the user to be able to tap on. What this allows you is, for example, having in a larger widget, you could then have different stock symbols, for example, and depending on which one the user taps on, the app should perform something different when it's opened. So you could have different links in a grid layout, for example. Okay, but in this case, we don't need it as there's just one symbol that we're talking about. So we can just use the .widget URL modifier on our outermost container vstack here. Okay, and that's already everything that needs to be done in the widget extension. So next we can move back into the main app and specifically into our content view and into the body of the content view. Now here, once again, on the outermost container, you can also do it, for example, in the list, but I will do it on the navigation view. You can have a modifier on open URL, and this allows you to, actually let me transform this into a trading closure syntax like this. This allows you to grab the URL that the app was opened with. Okay, and inside of this modifier, we can now grab the URL and work with it. And this is the part where we are actually going to talk about the scheme and the host. So we will just make sure that they are what we want them to be. So guard URL.scheme equals to stocks app. So this part here. Then URL.host equals to symbol, so this part here. And now we can also say let symbol equals URL.path components, and let's just take the first one like this, or the second one like this. Let's also say else, and if this doesn't work, we will just return out of the function. And now we can actually work with this symbol that we grabbed out of the URL, which is basically this last part here. And just for simplicity's sake, I will do it quick and dirty, so I will just add a state var symbol, and I will just make it an empty string in the beginning, and then at the top of our list I will just add a text of this symbol, just like this. Okay, actually, since the URL is not optional, we can remove it from our guard statement and make it a bit simpler, and then just say let symbol equals URL.path components one line lower, and then we can just say self.symbol equals symbol, and that way we assign what we just got here into our state variable. Okay, and that is already it. That is how the effect, or how you can actually send data from the widget to the app when the user taps on it. So let me show you again. Here's the widget, which shows data for the AAPL symbol. The user taps on it, and the AAPL symbol string is passed into the app. Okay, that's it for this video, and I hope you enjoyed it. If you did, please leave a like, subscribe to the channel, and I'll see you in the next one. Hey, this is Flo, and welcome back to the WidgetKit course. In this part, I will show you how to let the system, so iOS, know that the user is currently interacting with your app, which then basically means that iOS can suggest the user your widget even though they are not actively using it. So for example, if your user is currently looking at a specific stock symbol, like in our case, since we're working with the stocks app, and he always does that around noon, then your system, then you can give your system the ability to suggest your user your stocks widget every day at around noon, even though they are not, even though they haven't added the stocks widget to their home screen. To do this, there is actually a great session in WWDC 2021, and we're basically just going over the code here, and I'm showing you how to use this in the stocks app. Okay, so if you want to, you can just search for the video Donate Intents and expand your app's presence in the developer app or on the developer website for all of the WWDC videos, but we will just go over the code very briefly. Okay, so let's get back into Xcode. If you remember, then inside of our widget, we have an intent definition for our configuration intent. And this configuration intent is what allows the user to configure the widget, so in our case to set a custom stock symbol which they want to be displayed. Now in order to donate intents to the system, which is the way to let the system know that the user is using the app, we first of all need to have our intent in our main app target, like this. So you definitely need to have this check mark here. And in here we also need to say intent is eligible for Siri suggestions, and then in the suggestions area down here we need to add a supported combination of our parameters. It's very easy in our case because we only have one parameter. Just select it, hit add supported combination like this. Now we can select it here, write a summary and a description. Then we can also choose a default image, for example, your app icon or whatever, and then this would be shown when the intent is shown to the user. Okay, now we can go into our actual app. As you remember, this is a very simple app, so I'm just in the content view model. You can do this anywhere with a bit more context. For the sake of this video, I will just, first of all, make this all a bit larger and then hide the right hand side here. I will just create a function called donate intent, which you can then call whenever you want to donate an intent to the system. To use all of this, we also need to import intents like this. Okay, now we can create an intent. So let's say let intent equal configuration intent. That's the name of our intent definition. Okay, now we can say intent dot custom symbol equals a custom symbol. Let's just use a simple initializer here. So one with an identifier of, let's say, AAPL and the display name of Apple. So we could, for example, call this function when the user taps on the Apple stocks data, for example. Okay, now there's actually only one more thing to do to create an interaction and to donate this intent to the system. So let's say let interaction equal in interaction like this. Then we can just use this easy initializer. We can just pass in the intent that we want to donate, and then for the response, let's just pass it nil for now. You can play around with this later if you want to. And now to actually donate our intent, we just have to say interaction dot donate. All right, now we get a completion block here with a potential error, and you could handle this error here. You could, for example, say if let error equals error, so it's not nil, then you should handle it. You can also just print it out. Okay, and this is actually all that you need to do to donate an intent to the system. Once again, right now AAPL and Apple is hard-coded. In your actual app, you should get that data from somewhere, for example, when the user taps on one widget or does a specific action. Okay. Next up, let's look at how you can actually delete these intents. You might want to do this because you're saying, oh, maybe I shouldn't have donated it, maybe the user only once did this, or whatever the reason may be. So to donate the intent, you need to also give the interaction an identifier. So let's say interaction.identifier equals AAPL interaction. This should be unique, obviously, so maybe you should add a timestamp there or whatever it may be, and then save this identifier somewhere persistently in your app so you can access it once again later on. And now to remove this intent, we can just say in interaction.delete with identifier. We can pass in an array here, but we just want to delete this one interaction, so just pass in the identifier of the interaction here, and then we once again have a completion block where we could handle a potential error. So let me just copy the error handling from up here, paste it into the delete function, and that's already it. So let me go over it real briefly. You first of all create the intent that you need for your widget configuration and that the user is actually basically doing right now and that you want the system to suggest as a widget. So in our case, the configuration intent. Then we set the custom symbol to a custom symbol instance. We create an in interaction with the intent that we just created. We can optionally give it an identifier and then just donate our intent. This is all the code that we need, and then the deletion is even simpler. Okay, that's it with the video. If you liked it, please make sure to like the video, subscribe to the channel, and I will see you in the next one. Bye. Hey, this is Flo, and in this video I'm showing you how to programmatically refresh your widget through your iOS app. If you like my type of content, then please make sure to subscribe to the channel, like the video, and let's get right into it. So I've prepared here a very basic example. So this is just an out-of-the-box app with just a content view and the hello world text, as you probably have seen it 1,000 times. And then if I go to the home screen here, I also have a widget that just shows the current time from when it was created. So if we jump over into the widget definition here, the timeline provider is exactly the one that gets generated. Everything is exactly the same. I just changed the body a little bit so we see also the minutes and the seconds of the date when the widget was created, just so we can see in this video how the refreshing or reloading actually works. Okay, so we actually don't need this widget definition anymore. Let's get back into the content view. For simplicity, I will do everything inside of the view, inside of a button, but of course you can extract this logic into a view model, a service class, or whatever it may be that you're using. So first thing that you need is importing WidgetKit. Inside of WidgetKit there is one class called the Widget Center, which we can use to reload the timeline and to get information about all of the currently active widgets on the user's home screen. So to use that, let's replace this text here with a button, and let's call this button reload widget, just like that. And then inside of the button's action, which is here in the closure, we can just say widget center, use the shared instance, and then as you can see there's really not much to do here. So there are basically two functions that we can use: reload all timelines, which as the name says reloads all of the currently active timelines. For example, if you have different widgets that use different timelines, then all of them will get reloaded. Or you can reload a specific timeline using its kind string, which is this string over here that you pass into your widget configuration down here in the main widget. So back in the content view, we can just say reload all timelines when this button is pressed. So now let's run this app in the simulator, and you will see how easy everything is. So if we exit out of the app, then you will see the current time. The widget was initialized at 3:20:54 p.m. Now if we open the app and hit reload widget and go back to the home screen, then you can see the time updated, so the widget actually got reloaded. And what internally happens here is that your get timeline function of your timeline provider gets invoked again, so a new timeline is generated and is then obviously also displayed inside of the widget.
Hey, this is Flo and I'm back with another WWDC 2022 video for iOS 16 news, and in this episode we will have a look at widgets for your lock screen. It's actually super easy to add these, so let's jump right into it. This is an empty Xcode project, as always, nothing fancy here, and the first thing that you need to do is create a widget target. So let's go to File, New, Target, and search for Widget Extension. And let's just call it Lockscreen Widgets. Let's hit finish. Let's activate the scheme so we can debug it right in the simulator. And then you will see that we have the Lockscreen Widgets file auto-generated for us. Now in here, this is a very basic WidgetKit implementation. We have our timeline provider, we have our timeline entry, then we have our actual widget struct with a preview for it. And then we also have our SwiftUI view in here, which is called Lockscreen Widgets Entry View. Now, in this video, I will not cover how WidgetKit works by itself. So I have an entire series about WidgetKit, which will be linked in the description, so you can just check that one out if you're not experienced with WidgetKit. And in this episode, we will actually not care about the timeline provider. We will not care about the timeline entry either. What we do care about is our view, our widget, and our previews. So first of all, the Lockscreen widgets are just 3 new widget families. So let's go ahead into our widget configuration and add the supported families modifier. And here we will just support the 3 new accessory families. So accessory inline, accessory circular, and accessory rectangular. So these are the 3 new Lockscreen widget sizes or widget families basically. So now we've told the device that our widget extension only supports these 3 widgets. Next up, let's make sure we can see all three of them in our preview on the right hand side. So first of all, let's give this preview a display name and let's call it inline. And then here for the family, let's say accessory inline. And then we can just copy paste that 3 times. So 1, 2, 3, one more for the circular and one more for the rectangular widget. And then let's also change the display names here. Okay. So now with these name changes, we can actually see the widget names here or the preview names here at the top bar here in our preview section. Next up, we want to display different things depending on the size classes. So we need to grab our widget family from the SwiftUI environment in our actual view. So for that, we will use the add_environment property wrapper, and the key path is just widget family. And let's make that a variable also called widget family. Then let's copy this text here and replace it with a switch on our widget family. Now, if we autocomplete this, there will be a lot of different cases here, which we don't actually all need. So let's get rid of all of the cases that we don't need. And let's just add a default case that says not implemented. While debugging, you might be able to get into this default case, but when the user actually has the app installed, this should never happen. Okay, so what do we want to display in these 3 different cases? I will just give you some examples so you can build your widgets on top of this. Once again, if you want more detail about how timeline providers work, how you can pass data to your widget and so on, you should have a look at the video description where my entire free WidgetKit course from last year is linked. It's pretty much still up to date, so there weren't many breaking changes this year, luckily, so you can just have a look there. But let's continue here. So I will show you a new view as well, which is the gauge. For the value, we will just pick an arbitrary number. This is just an example here. You would obviously get your data from somewhere, maybe not even display this type of view, but something custom, maybe an image, whatever it is. And then in here, we will just have a text label of our entry.date with a format of .datetime, and we only care about, let's say, the year maybe. Okay, so let's copy that into the inline family as well. And then for the rectangular, I would just put a text view directly inside here. So maybe something like this, just the entire date, for example. Now by itself, these gauges will not look very good. So we will have to customize them a bit. And there is a gauge style modifier, and we will just use accessory circular for the circular one. And I think I actually mixed them up. So for the inline one, we want our text, and for the rectangular one, we want the gauge. So now inline is just a plain text, and I will show you in a second on the simulator where each of these can be placed and how they will then look on the actual device. Now circular will be this little thing that you might already know from your Apple Watch complications. And then rectangular is a little bit larger, just like that. Let's go ahead and run this on an iPhone simulator so you can have a look at where each of these can be placed and how they will then look in reality. So you might run into this little error here, and I don't know why it happens, but when I run the widget extension again, it usually goes away. So now let's press Command L to lock the simulator, and then let's press the home button to unlock it again. So we're on the lock screen. Now here on the lock screen, you can just press and hold and tap Customize. And then there are 3 different sections. At the top section, we can add this inline widget here. So it will just be appended to the date. And then at the bottom section, if we go into our lock screen test app, we can see our circular and our rectangular widgets. So let's add the circular on the left side and the rectangular on the right side. And now if we press done and go into the actual lock screen, you can see your widget in action. Now, once again, if you want to learn more about how WidgetKit actually works, how you can pass data to your view and actually display some useful information, then you should check out my free WidgetKit course linked in the description. This was just an intro to find out how to add widgets to the lock screen now in iOS 16. Learn about iOS 16's new ActivityKit and how you can build refreshable and dynamic lock screen widgets with WidgetKit. Hey, this is Flo, and in this video we will look into using WidgetKit and ActivityKit to build live activities for iOS 16. For that, of course, you will need Xcode 14. Right now it's still in beta, so you will have to download that from the Apple developer website. We will get right into it by going to File in your menu bar, New, and then selecting Target. And then you can just search for Widget Extension. I'll just call it Tutorial Widget. Make sure to not select Include Configuration Intent since we will not be using that. Hit Finish. You don't need to activate the scheme right now. And now on the left side, you will see that the usual WidgetKit stuff got auto-generated for you. Now we will actually not be needing most of this. So we will not be needing a timeline provider. We will not be needing a simple entry. And let's also get rid of the preview provider for now. So we will just have our view and our widget structs. Next, let's get started by importing ActivityKit. Once again, ActivityKit is only available in the Xcode 14 betas. This feature, as far as I know, will also not ship with the first iOS 16 version. It will probably be available later on in December or January. That's how it usually goes. Okay, so right now we are using a static configuration for our widget body. As you might have already known from my WidgetKit tutorial series, there is the static configuration and there is the intent configuration. You're using the static configuration for normal widgets and the intent configuration if you want the user to be able to, for example, select a sports team or a currency or whatever it may be, so the user can actually configure the widget by long pressing on it on their home screen. That is not what we need right now. What we need instead is a new configuration called activity configuration. Here you need to pass a type of attribute and then you get a closure in which you can initialize your view just as before with the other widget configurations. So in here we will get a context, and then here we can create our activity view. Next, let's look into what this attributes struct does. So for that, let's go into our main app in the sidebar here, and let's hit Command N to create a new Swift file. I will call this timer attributes because we will just be making a very, very simple timer. And now, before you create the file, make sure to select both targets because you will need these attributes in both your main app to start and update the live activity and in your widget extension. So let's hit create. In here, let's once again import ActivityKit, and let's also import Swift UI. Okay, so we can go ahead by creating a struct called timer attributes, and this struct has to conform to the activity attributes protocol. In order to conform to the protocol, we will need a public type alias. We will call it timer status, and this is for the content state. And the content state itself is basically all of the data that is shown in the live activity widget and that you can refresh from your app. This is basically like an add state variable in your SwiftUI apps. That's how you can imagine it, I would say. So let's create a public struct called content state. This needs to conform to codable and hashable. So in our example, since we're just creating a little timer widget, we will have a variable called endTime, and that is a date. Now make sure to make it a var and not a let constant. Otherwise you will not be able to update your widgets or your live activities state. And then let's also give this timer a name. So let's say timer name, and this is a string, and we will put this outside of the content state because we don't actually want to change the timer name when updating the live activity. Okay, so going back to the widget now, we will specify our timer attributes.self as our attributes type. And then in the closure, we will create our view. So let's get rid of this pre-generated view and let's call ours timer activity view. This obviously conforms to the view protocol, so it needs a body. What it also needs is this context that we get in here, and the context contains our attributes and a bit more info, but we only really care about our attributes. So let's say let context be a constant of type activity view context, and this has a generic with our attributes type. Now, looking at this first, I get that it's a bit confusing, and I was also confused looking into this, but it actually becomes very clear once we start writing the iOS logic to start, update, and stop this live activity. So for now, we will just have a text with the timer name and then a text showing the end time as like a countdown style. So for that, we will create a VStack with an alignment of center. This should actually be the default, so we can get rid of it. And then in here, we will have one text element with our context.attributes.timername. And we will give this a font of headline. Now, obviously, we're not building any fancy UI here. If you're building a fancy live activity based on this video, tweet it at me. I'd love to see what you're coming up with. And then let's also create a second text element with our context.state. And this is that content state struct that we introduced here. Context.state.endTime is what we're interested in. And there's a new style initializer here where we can specify a style of timer, and then it will automatically count down. Let's also add some horizontal padding to our VStack here. Okay, and then lastly, and then we're already done with the WidgetKit extension part, we can just use our timer activity view with the context that we are passed in here. And that's already it. Now let's move on to our content view and all of the logic that you can add in your app to start, update, and stop these live activities. Now for that, let's build a very simple UI. Let's give this VStack a spacing of 16. And let's replace all of this in here. Let's add one button to start an activity. And then let's add another button to stop an activity. Let's give these a button style of bordered, prominent, and a control size of large. That's just a tiny bit of styling here. Okay, next let's implement 3 functions, one to start, one to update, and one to stop our activity. So let's create a first function called start activity. And in here, there's basically 3 steps that we need to take. First, we need to create our attributes. Then we need to create a state or the initial state for our attributes. And then we can already create or request to start this activity. Okay, so let's say let attributes equal our timer attributes that we just created with a timer name of, let's just call this dummy timer. Next, let's create a state. So let's state equal timer attributes dot timer status. And this is the type alias that we created here with an end time of the current date, adding a time interval of, let's say, 5 minutes. So this will be a 5-minute timer when we initially create it. Next, we can say try, because this next function is can throw errors. Try activity of timer attributes, and I think we need to import ActivityKit here actually. Okay, dot request with our attributes and our initial content state. And then very important here, you can either control your live activities via your actual app, so what we're coding up right now, or you can control it via remote push notifications. In that case, you will need to specify a push type here. In our case, since we're not doing that, we will just say nil for the push type. You actually have to add the nil here because the default, I think, is token, and that will actually not work in the simulator if you haven't registered your app for remote notifications. Okay, so really make sure to add the push type of nil here to your activity request. Okay, this actually returns us a activity. So let's make sure to save that to a state variable. So we will create an add state, private var activity, and this is an activity over the generic of timer attributes. And this is nil in the beginning because when we open the app for the first time, obviously we don't have a live activity running right now. This is just to keep track of it so we can update it and end it later on if we so please to. And now we can just assign that new activity to our activity state. Now we can call this start activity function in our first button. Next, let's have a look at the stop activity function. So let's create a function to stop activity. First, we need to update our activity's state. And then second, we can just request the activity to end. So let's say our new state is timer attributes dot timer status with the end time of now. And then this next part is actually async. So we will need to wrap it in a task, and we will just say await activity dot end using our new state here. Oops. And the dismissal policy of immediate. You can also tell it to dismiss only after a few minutes, for example. Okay, and then lastly, let's actually call that function here, and let's create the last function. We're not calling that, I'm just creating it to show you how to actually update an activity. So let's say func update activity, and this is also super simple. First, let's create our new state. And I think you're getting the pattern by now. So we have a new timer status with date, and let's say the new end date is adding time interval, let's say 10 minutes, so 60 seconds times 10. And then you can just say activity dot update using this new state. And this is once again async, so we need to wrap this in a task and then await the completion of this method call. Okay, so as you can see, we always have to keep around or create a new state, and then we can either request to create the activity, request to end the activity, or request to update the activity. And before we can actually try out the live activity, there's one more thing that we need to do, and that is to go to our project, go to the info.plist, and we need to add NS supports live activities. So let me quickly copy that over, just hit a plus anywhere. And for this, you will have to set this to a Boolean and of course select yes. And now we can run it on the simulator, and now it should actually work. Okay, so just to make sure, opening up the lock screen here, no activity is running. Now we hit the start activity button, go back to the lock screen, and then you can see we have our dummy timer here. So just our timer name, and then this little text field counting down. Now you could use this for like a delivery app, or if your user needs to wait for something in a game, and then with the timer style that we specified, this will automatically animate. And now we could also say stop activity. Then if we go back to the lock screen, it stopped, and it's immediately stopped because that's what we specified for the dismissal policy. Learn how you can use ActivityKit, WidgetKit, and SwiftUI to support Dynamic Island in your iOS 16 apps today. Okay, so this video will go through ActivityKit and WidgetKit and a bit of SwiftUI, and explain to you how you can add Dynamic Island support to your apps in a few different steps. First of all, we will be tackling live activities, how they work, how you can start and stop them. Then we will be adding the widget extension, have a look at the lock screen live activity, and at the very end we will add the Dynamic Island support and add different views that are displayed in the Dynamic Island. I have already prepared a starter project here, and it's just a very basic time tracker app. It has no persistence or anything. It's just a big green button, and if the user clicks it, then the timer will start, and the time will be measured. And then when they click it again, the timer is stopped. There's really nothing saved anywhere or anything. This is just a very, very simple example to get us started with this project. So first of all, when talking about live activities, you need to be aware that they are state driven. So you don't actually update the SwiftUI views that are shown in the activity. You just update their state, similar to any SwiftUI app really. And that state is called activity attributes. So first of all, let's set these activity attributes up. So I'm hitting Command N here to create a new Swift file, and I will call this time tracking attributes. Let's hit create. In here, we need to import ActivityKit, and then we will need to create a struct, give it that exact same name as the file. So in our case, time tracking attributes, and this will need to conform to the activity attributes protocol. In order to conform to the protocol, we will need a type alias and a content state. So first of all, let's create a type alias. It will be called time tracking status, and it stands for our content state. And this is basically all of your add state variables that you would usually have in your SwiftUI views. Where does this come from? Well, it doesn't exist yet. We will have to create a new struct called content state. And this struct needs to conform to both codable and hashable. Inside of this struct, we can now define all of the variables that could be updated over time. If we have variables that are not part of the state and that are just fixed, we can also leave them outside of the struct. So in our case, we just have the start time of the timer, and that's just a date. And to use date, we need to import foundation. Okay. So this is the state that drives our live activity. It's just a start time. We don't need anything else. The rest will actually be handled by a very handy overload of the text view in SwiftUI for us. Okay, so now that we have these attributes, let's have a look at how we can start live activities from inside of our SwiftUI app. Okay, so let's have a quick look at the logic here. We have one button, which is this green circle right now, and it either says start or stop, and it's either green or red depending on the state. So when we are tracking time, or when we are starting to track time, which is basically this if clause here, then we want to start the live activity. And if we stop tracking time, we want to stop the live activity. Since live activities are part of the ActivityKit framework, we of course need to import ActivityKit at the top of our file. To start a live activity, there are just 3 simple steps. So first of all, we need to create an instance of our time tracking attributes. So let's say let attributes equal time tracking attributes. Notice that this is just an empty initializer because our attributes don't have any fixed data associated with them. If you want to have a look at another example here, I will link another video that I made on ActivityKit a few weeks ago in the video description. Now that we have the attributes, we need to give them a start state. So let's create a new state, and this is our time tracking attributes dot content state, and we basically want to give it the start time that the activity or that the user wants to start tracking their time at. So in that case, they just want to start tracking their time right now. So we create a content state with the start time of now. And next, we need to request to start the live activity. So we can just say try. And now this is a bit complicated here, but you will get the gist of it. So there's a generic class activity, which takes in our time tracking attributes as a generic. And then on this class, we can just call the request function. We pass in our attributes and we pass in our content state. And now one very important part here is there's also another argument that has a default value, hence why it's not shown, but we need to actually provide nil here for the push type. Otherwise the live activity will not actually be shown to the user. And that is basically already it. Now you see Xcode displaying a warning here, and that's because this request function returns a activity. So let's option click on it. Then you will see it returns an activity of our attributes. We don't really need that, but for the sake of this video, let's actually save that for a state variable. So let's create a state variable called activity, which is of type activity with the generic over our time tracking attributes. It is optional since at the beginning, when starting the app, there is of course no activity running. And then we can just assign everything here to our activity variable. And just like this, we have already created our first live activity and it's already running on the user's device. Next, let's have a look at how we can end that live activity, and it's equally as simple. To end the live activity, it's almost as simple as starting it. So we actually still need our start time, so I'm not setting it to nil quite yet. Remember, the start time is just our local variable here to track when the user started tracking their time, and it's also used to display this little timer up here using the relative style of SwiftUI's text. So we just need to create a new state, which is of course a time tracking attributes.content state. The start time is the exact same as before, but we need to pass this to the next function call that we will do. This function is asynchronous, so we need to wrap it inside of a task. And then we can just say await our activity that we have saved here earlier. This is of course optional. And then we can just say end using our state, and the dismissal policy, we will just say it should immediately dismiss. There's one more little issue here, and that's that our start time is actually an optional date. So we can just say guard let start time else return, just to make sure that it's not optional. And then at the bottom here, we of course need to say self.starttime equals nil, because this variable overshadows this state variable. Okay, so now we already have the logic to start the live activity. We also have the logic to end the live activity. Before we can actually have a look at adding the widget extension and displaying the live activity on the lock screen or dynamic island, there's one more thing we really need to do. And that is to go into our project file, go into the info tab, click plus anywhere in the list, and add a new key called ns supports live activities. And we need to set that to true, of course, or to yes. With this in place, we can now actually start live activities, but there's nothing to see yet as we haven't added a widget extension quite yet. So let's have a look at that next. Okay, so to add a widget extension, just go to File, New Target, search for widget, give it some sort of name. So I will just call it tutorial widget. I will not say that this should include a live activity because we will just write that from scratch. Hit finish. I don't want to activate the scheme. And now we will have a widget and a widget bundle. And I will actually get rid of everything in the widget right now, just to show you how you can set it up yourself. So first of all, we're using ActivityKit again. So let's import ActivityKit. Now there are two structs we need to set up. First of all, the widget struct, and secondly, our actual SwiftUI view that is displayed on the lock screen. So let's start by defining the widget. And let me have a look at how it's called here in the bundle. It's called tutorial widget. All right. So let's copy over that name. And this one, of course, needs to conform to the widget protocol. Now the widget just needs a body, and that's the wrong autocomplete here. So let's just say var body is some widget configuration. All right. And then in here, we can just define our activity configuration. This now has a few different arguments, and we'll have a look at each of them separately. So first of all, we need to pass in the type of our activity attributes. You remember we called them time tracking attributes, but if we paste that in here and of course add the .self, Xcode will complain because the time tracking attributes are just part of our basic app and they're not part of the widget extension. So let's go to that file, open up the inspector on the right, and make sure it is also a member of the widget extension target. And just by doing that, you will see the syntax highlighting now picks up on these attributes and the error is gone. Next up, we have two closures here. The first closure is for the view that is displayed on the lock screen as a live activity on all iOS 16.1 and above devices. And then the second one, as the name suggests, is what is displayed in the dynamic island. This of course only currently works on iPhone 14 Pro and iPhone 14 Pro Max devices, as none of the other devices have a dynamic island. What we get into these closures is an activity view context that just contains our attributes and just contains the state or the content state of our widget. So let's just call these context here, and the same for the dynamic island closure. And now inside of this activity configuration, we can just add some sort of SwiftUI view. So I like to extract that into its own view. So I will just call this time tracking widget view. This is a SwiftUI view. It of course has a body, and it takes in our context that we get here as the closure parameter. So we will just say let context, and that is an activity view context over our time tracking attributes as a generic. I think by now you have noticed that ActivityKit heavily uses the generic over the activity attributes protocol that we have defined. And now in the body we can do whatever. If you want to learn more about this, you can have a look at my ActivityKit video that I already mentioned beforehand, which is linked down in the video description. In this case, we will just do a very simple UI here, and for that we will basically use the same thing as we did in the main app. So we will just use a text with a relative style. So let me just add a text with this overload here where we pass in a date and then a style of relative. Now this will not be a pretty widget whatsoever, but it will get the job done. And the date is just our context.state, which is our time tracking attributes.content state, so that inner struct that we defined earlier, and then of that state, it only has one variable, which is the start time. Okay, so now we can use this time tracking widget view here in our activity configuration, time tracking widget view, and we just pass in the context that we get here inside of the closure. Next, let's have a very quick look at the dynamic island. This does not take in a regular SwiftUI view. Instead, it takes in an dynamic island. There's this initializer here which has a bunch of closures, and I will explain them to you, and then you can create your own designs in your own time. So the first one is the dynamic island expanded region, and this one actually also needs its own type here. So this is not just a SwiftUI view. So we will need to create dynamic island expanded region with a position and content. So as a position, I will just say I want this to be leading. and then the content is just a SwiftUI view. Now, to make it easy to understand which of these closures here resembles which area of the dynamic island, I will just put their name inside of text, and then we will have a look at what the simulator tells us. So this is the expanded region. Next is the compact leading type. So I will just say CL for compact leading. And once again, we'll have a look at this in just a second. Then we have compact trailing, CT. And then we also have the minimal type. Inside of these, you could add countdowns or whatever, of course. This is just for us to have a look at how it actually behaves. So now let's make sure we have selected the iPhone 14 Pro, so we have the dynamic island. And now we can actually run the project in the simulator. Okay, so here's the app. It looks exactly the same as in the preview, of course. Let's press the green start button and you will see it will start counting up. There is nothing in the dynamic island right now because the app is running. So let's go to the lock screen. And let's say keep here. And there you have it. This is our time tracking widget view. As you know, it's just a super simple stuff. It's just a SwiftUI text that counts up how long we've been tracking time right now. Of course, you would definitely want to improve this design here. I'm just showing you how the API works, and I'm not a graphic designer, so you can do that yourself. So as you can see, the lock screen support works like a charm. And now if we go to the home screen, you can see the app automatically expanded into the dynamic island, and we can see both the compact leading and the compact trailing areas here. So they will be shown at the same time in this case. And then if we long press on it, we will see the main area. So you will notice that we did not see the minimal area here where we would just have displayed an M, and that's because that is only displayed if a second activity would be running at the same time. So I'm afraid I can't show you that right now, but you've probably already seen how this works. It would then be just its own blob on the side here with just one of these two areas, whereas if your activity is the only one running right now, you would have both compact leading and compact trailing to yourself. And if the user presses and holds, it would show the dynamic island expanded region. Now we specified the alignment of leading, so of course our text is leading aligned here. You can play around with this as much as you want. And then again, if we go to the lock screen now, you will see that the live activity is displayed on the lock screen as well. Even if we lock the device, then it will automatically gray out. And the SwiftUI animation is actually smart enough to only show the minutes then instead of also the seconds as well. Just like this. And then we can click that live activity, go back to the app. You will see the timer is synced up now. I'm sorry for the German formatting here. Updating to the newest Xcode version must have messed up my language settings. And now if we hit stop, then it's gone. And then you will also notice that it's gone from the lock screen as well as the dynamic island. Alright, so in this video you learned about ActivityKit, what activity attributes are, how live activities work, how you can start and end them. You learned about a very important info.plist key called ns supports live activities. You learned how to write your own widget extension with an activity configuration for a lockscreen widget or a lockscreen live activity and dynamic island support using the dynamic island type and the dynamic island expanded region type. And then you just used SwiftUI views in there. We just had examples here, but you can feel free to be creative. If you're working on a cool ActivityKit app, feel free to tag me on Twitter at FloWritesCode.
By default, CoreData is not shared with your app's extensions. I will show you how to get it working for all of your projects. And speaking of projects, I actually made a free macOS and iOS app called LaunchBuddy to help you structure your app's releases and updates. So before we get started with how to share your CoreData stack with your app extension, let's first have a quick look at the demo project that I have prepared. It's a very simple iOS application. It just has a list here of all of the items. An item is my entity in CoreData. An item has a string, I call it text, and a date, which is just a timestamp of when it was created. And then in my content view, I just have a list of all these items showing the text and the timestamp, so nothing fancy whatsoever.
And just to be clear, all of this data over here comes from our preview persistence controller, and the persistence controller is basically exactly the one that gets auto-generated when you select that CoreData checkbox when adding it to your when creating your project and adding CoreData to it. So I even left in all of these comments and fatal errors and so on that I would usually get rid of, just to make it easier to understand for you. So I have a preview controller here just generating some dummy data that's just used for our SwiftUI preview here. We can also have a look at the simulator. So there is a text field at the top and a save button. So in the text field we can enter any string. So let's say item number 1, hit save, and then it will get saved to CoreData and also displayed in the list here. And then there's also a widget, and the widget just shows how many items are currently saved in CoreData. And the widget shows 0 because our CoreData stack is not connected from the app to our widget extension right now. Alright, so what I have in the widget extension, I basically just created a function to get all of my items from CoreData using the shared persistence controller. That works because for the persistence controller, I opened the navigator here and made sure that the target membership is both my main app and my widget extension. You will definitely have to do that for your persistence controller and also for your CoreData model. I already did this, but this is the first step that you will have to do to connect them. And then inside of my widget extension, I just get the data using a simple item.fetch request and then context.fetch that request. And then in our view, I just say entry.itemCount, and item count is just a count of all of the items that we have in CoreData. So super simple stuff, really nothing fancy going on in the widget, but as you can see, the widget doesn't reflect the actual count of items in our CoreData stack. Now to get started, let's close everything here and just open up our persistence Swift file or our persistence controller. And let me first of all get rid of this huge comment here because it's just in our way. And the thing that we now need to set up is an app group. An app group is usually meant to link data or to share data between different apps by the same developer, but it can also be used to share data between apps and its extensions. So let's go into your Xcode project and select your main app target, go to signing in capabilities, and under capabilities, select app groups. Loading these app groups might take a few seconds, and then you can just hit plus and create a new app group. So I would recommend you to keep that group dot at the beginning and then just enter your bundle identifier. And then also make sure to copy that identifier so you can reuse the exact same one without making any typos later on. Hit OK. And then this will take a few seconds. Then you might have to refresh this list here. And now your app group is set up for your main app. Let's do the same in the widget extension now. So let's hit plus again, select app groups. And then you can just scroll down in your list of app groups. And with that, our app groups are set up. Next, as you might know, CoreData is basically just a wrapper about around an SQLite database. And that database is really just a file stored on the user's device. Now, currently it's stored in a directory that's only accessible to the main app. And we want to now tell our persistence controller to store it at a place where the entire app group can access it. For that, let's first write a little convenience extension for URL so we can easily access that URL that we want. So let's say public extension on URL, and let's create a static func store URL for our app group, which is just a string, and a database name, which is also just a string, and this then returns a URL. So we will use the app group identifier, the database name, which is the name of your CoreData file, and then create or give us back the URL for that database. So in here we will say let file container equals file manager dot default dot container URL for security application group identifier app group. If that fails, we will have to throw a fatal error because this is not a throwing function and it's also not an optional return type or a result return type. So we will just throw a fatal error, maybe add a little comment saying unable to create URL for, and then pass in that app group. And if we got that file container, we can just say return file container.appending path component, and this path component should be our database name .sqlite. This is something that I basically copy over into every single one of my CoreData projects. I think I found this on Stack Overflow a few years ago, so just a very handy extension to use for app groups and CoreData. Next, let's actually use this. So we don't care about our preview up here, so let's collapse that real quick. What we care about is the initializer of our persistence controller. So right before we check whether it's the preview, basically, that's this if check here, we will have to grab our URL. So let's say let URL equal URL.store URL for, and now this for here is our app group identifier, which you hopefully copied earlier. And then the database name is just the name of your database file. So in my case, my text storage. Next, we need to tell our persistent container to actually use this URL. So for that, we will create a persistent store description. So let's say let store description equal an ns persistent store description given this URL. And then we can say container.persistent store descriptions equals this description right here. Then we can keep this if in memory check, and we can also keep this load persistent stores function. And with that set up, now let's run the app again on the simulator and see what changed. Alright, so the first thing that you must notice is that our CoreData list is empty again, and this is a big issue. And that's why I recommend you to always start with an app group. No matter if you plan to add widgets or any kind of extensions, it's really better to just always start with an app group, start with this exact setup, and then you can add your widgets without losing any data or having to migrate any data. If you already have a CoreData stack and your app has already been used for quite a while and you now want to add widgets, you will have to manually migrate the data. So you will have to grab the data from your old SQLite file and put it into the new SQLite file. This is not part of this video, it's a bit too complex, but you can look that up yourself. That's why I recommend to always start with an app group for your app, even if you don't plan to add widgets in the near future. This is also helpful for intent extensions, for example. So now let's actually try out our implementation. So let's say this is my first text entry. Let's hit save. And it is saved indeed to our list. And going to the home screen now, you will see that the widget shows a 1, which is the count of items in our CoreData SQLite file or in our CoreData storage. It takes just a few steps to use user defaults with your widgets and your main app. Stick around to learn how it works. So I have prepared an incredibly simple example project here, and basically it's just a default SwiftUI project, but I have added an app storage property wrapper here, which makes it possible to use user defaults in SwiftUI. By default, it's an empty string. The key is my default string, and then I just have a text field which is bound to that my string variable, so to that value in user defaults. App storage is just the wrapper for user defaults, as you might know, and then we can enter some text there and it will get saved to user defaults. And I've also prepared a widget extension here which has a function getMyString, which just takes the user defaults and gets the string for the my default string key, which is the key that we used here in our app storage property wrapper in our main app. And then that gets passed into our timeline entry and then shown into our widget view right here. And as you can see, this doesn't really work in the preview, so I'm just showing a preview string there. And now having a look at the simulator, we have this text field here, and if we now enter a random string like random string, and then we go to the home screen and have a look at the widget, you will notice that the widget says no string. And let me actually quickly add something here. just so our widget always refreshes. So let's import WidgetKit, and I'll just say widget center.shared.reload all timelines, just so when we press enter, the timeline actually gets reloaded. So let's run that again in the simulator. And let's hit enter. And now, even though the timeline got reloaded, it still says no string, because that's the default value that we give back here. And it's obvious because we haven't written to the my default string key inside of the widget extension, and the widget extension currently cannot read any data from the main app. So let's implement that. There are just two steps that you actually need to do. The first one is to enable an app group, so the two extensions or the two targets can communicate with one another. If you're interested in how that works for CoreData, I have also made a video just on that, so you can check that out next. And then the second step is to just use the correct user defaults instead of the standard one. So let's go to our project settings and go into our main app and add the app groups capability. And then let's hit plus here and create a new app group. So I like to call mine group dot and then just the name or the bundle identifier of the project. So in this case, it's share defaults. And I'll just copy that, hit OK. Might have to refresh there in a second. All right, that looks good. And now let's do the same for the widget extension. So go into the signing and capabilities tab, add the app groups capability, and then just select your app group. There it is. And that should be set up and good to go now. So next, we will have to tell SwiftUI to actually use the user defaults for our app group. And to do that, you can just go into your abstract, and let me re-indent all of this. And then on your content view, you can say default app storage. This is a view modifier that not many people know of. And here you can pass in a user defaults instance. You will create one using a suit name. And then the suit name is just the identifier of your app group. Now, this one is optional. Now, we know that we have created this app group and that both the main app and the extension are part of the app group. So I would argue that it's safe to force unwrap. If you don't want to force unwrap, you can also grab this user defaults thing here, call it defaults, and then embed this in a if let check. So let's say if let defaults equals this user defaults, and then we can use it as a default app storage. And else you can just show some other UI like failed to load user defaults. You would actually implement your own error message here probably, or handle this in any other way. This is just a way to use the suit name user defaults without actually force unwrapping it. And then we basically have to do the exact same in our widget extension. Now we can't really use the view modifier there because we're not using the app storage property wrapper. But nevertheless, let's copy this string here, or this initializer here, and go into our widget. And then in the getMyString function, really just wherever you're accessing the user defaults, instead of using userdefaults.shared, we can get rid of that and use our suit name user defaults. And we also have to make sure to optionally change this down here, just because this initializer is failable, so it can return nil. And now let's run this again on the simulator. You will notice that our random string from before is gone because we're now using the new user defaults instance. So let's enter my string, hit enter to refresh the widget. And then on the home screen, you can see my string is displayed in the widget, even though the default would have been no string. So this is actually now correctly synced up between the main app and the widget. And of course, you can also write stuff to user defaults in the widget and then show it in your main app, even though I'm not really sure why you would want to do that, but I'm sure that there are options for that. Finally, widgets can now be interactive, meaning that you can place buttons inside of your widgets and perform an action when they're pressed. And the widgets are even animated throughout the changes that happen with this button press. So in today's video, I have already built such a widget and I will go over it just to show you how everything works and how you can implement it for your own widgets. So this is the example application that I have right here. And on the left hand side, I will show you the code, and on the right hand side, the actual app in the simulator. So I write and read a value called count from app storage, which really is just the SwiftUI wraparound user defaults. And when I press this top button here, then I just increase the number. And when I press this bottom button here, I will reset it back to be 42. So how does this work? I actually implemented these two buttons in completely different ways. So the top one is just a regular button that increases our count value from app storage. And then also reloads all of our widget timelines just so everything on the home screen is up to date. But the bottom button here, I don't have any logic inside of there. Instead, I am using this new overload here where I can provide an app intent. And app intents are the magic ingredient to make your widgets be interactive. So just to set this particular widget up, I have created a app group for both the main app target and the widget extension. Both of them use the exact same app group. And then in my app declaration, I have added the default app storage modifier, which lets me use this app group's user default suite instead of the standard one, which is not synced with WidgetKit. I would have preferred to make this video about Swift data in interactive widgets, but I have tested this for countless hours and I just can't get Swift data to sync across app groups. This is probably a bug in Xcode 15 beta 1, so you can check the pinned comment below this video if you're into Swift data for interactive widgets, because I will link a video there once it is fixed on my end and I can get a video up on the topic. But for now, we're using user defaults in an app group, so we can get rid of that here. And then that is basically everything that we care about in our content view. It's very basic, just a button, an app storage value called count, and a button that calls the set count intent, passing the value 42 in this case. So let's now have a look at our widget extension, and I've folded everything up here so we can go through it one by one. So first of all, this is the widget definition, very simple stuff. I'm just using a static configuration with my timeline provider that I will show you in a second, and my widgets entry view, which is also just a dummy thing, which I will also have a look at in a second. And then also I totally forgot to show you the widget in action. So here it is right there on the home screen in the simulator, and you can see the increase button works and the set to 42 button also works. So let's have a look at our timeline provider. This is almost exactly the same thing that you would usually have, but since I added a count integer to my simple entry, which got auto-generated, I just added this single line of code here. I also created a getCount function as part of my timeline provider that just takes the shared store from UserDefaults and returns its value. If for some reason it can't access the shared store, it will return -1, which is a value that our widget usually cannot display. And then in all of these functions here, wherever I create a simple entry, I just appended the getCount function here to get the count. Everything else is exactly the default setup, just so you know where to get started. So lastly, let's have a look at our widget's entry view, which is the actual view displayed here inside of the system small widget. Also very simple stuff. I just have a text of our entry.count with a format of numbers since it is an integer. And then I just have two buttons. One button to increase the value, one button to set it back to 42. First one uses the increase count intent, passing no parameters. Second one uses the set count intent, passing the value 42. We'll have a look at these intents next. But very important, if this is your first time working on iOS 17 widgets, but you have already worked with widgets in the past, there is now a new modifier that is required in order for you to build your widgets for iOS 17, which is the container background. And here you set your background that you want for the widget. So .background is basically the default. Instead, we could also do some color here, but I will just go with .background for simplicity's sake. So button calling an intent. How does that intent look? Well, as I told you, I created two, one simple example, which is the increase count intent, and then a bit more complicated example, but also really not that bad to understand, which is the set count intent. So these intents are just Swift structs coming from the AppIntents framework, and the struct just has to conform to the AppIntent protocol. In order to conform to that, you only need to implement two things. First of all, you need to implement a localized string resource called title, being a static var. And this is basically just the name or the title of your intent, as it might be displayed in shortcuts, Siri, or whatever. So I just called it increase count. And then you need to implement this async throwing perform function, which returns some intent result. We don't even care about that intent result in this example right here. And then in here, the perform function is just the logic that you want to execute when this intent is being run. So in our case, the logic I want to execute when the increase button is pressed. So for that, I once again take the shared user default store. I get the current count and I increase it by 1, saving it back into user defaults. And then I just return an empty result. If you're interested going into more detail about the AppIntents framework, please just leave a comment down below and I'll make a video about it as well. And then as well as the increase count intent, I also created the set count intent just to show you that you can also pass data into your intents. For that, you can create a variable, I called it value, which is just an int, and then attach the add parameter property wrapper to it, giving this once again a string value so it can be used in other system features. Once you have added your own parameters, you will have to create an empty initializer and then probably a custom initializer to actually pass these values like we did in the widget right here. So we passed value 42. This is our custom initializer right here. Without doing that, you will not be able to pass values to the parameters, so you will definitely have to create your own custom init. Shouldn't be too much of an issue though. And then in here, the perform function is very trivial. You can have a look at that yourself. The only other very important thing for your intent is, as you can see, mine is inside of the widgets group. It can be wherever you want in your project, but you have to make sure that it is a target member of both your main app, which is called group test in my case, and your widgets extension. That is needed because you're actually using this type right here in a widget extension and right here in your main app. And having a look at the simulator again, I am able to increase my count, set it back to 42, and when I open up the app, I can also increase it right here. And since I use that reload timeline function, it will actually also reload the widget and be updated live. And we also have this little animation here, which you can customize using SwiftUI's transition and animation system. I absolutely love how this got implemented, and I actually believe that using intents for app logic might be a very nice architecture going forward, because that way you can expose basically anything in your app to shortcuts and Siri. Might be worth to think about that for your app, to use this intent button initializer in some more places of your main app, not just in the widget. In addition to the interactive widgets that I showed you in my last video, widgets can now also be configured using the AppIntents framework instead of the old intent definition file approach that I already showed you about 2 years ago in my full WidgetKit course. So today I've prepared this simple colored widget here that just consists of a single color, but when we press it, we can edit the widget, select an accent color here, we get a list of recommendations. I will just select blue in this case, go back, and then the widget will use that color internally. This is a very simple example, but I will go through it one step at a time. I've already laid all of this out, and then hopefully at the end you're able to implement configurations using AppIntents for your own custom data types in your own widgets. So to get started, let me quickly show you the setup for the colored widget, and then we can jump right into our select color intent, which is the app intent that is being used to configure this widget. So the most important thing to get started with these app intent configured widgets is to, instead of using an intent or static configuration. You're now using a app intent configuration. And for that, you can pass the intent that you're using and the timeline that you're using. The timeline also has to be an app intent timeline provider, not just a timeline or intent timeline provider. So very important that this is now a completely new type for our timeline provider, and for our configuration, you're now using the app intent configuration instead of the intent configuration. And then the rest of this setup is completely the same as always. I just added one little tidbit here that is also a new feature in iOS 17, because widgets can now have content margins, which is basically an inset to the widget on the side here. And using the content margins disabled modifier, I'm just getting rid of that. Now, in reality, I would be very careful using this modifier, because, for example, if you're running your widget on watchOS, then it probably really makes sense to keep the content margins. There's also now a new view modifier that you can use to set the content margins for your views, but that is a topic for a different time. Right now, I just wanted to quickly go over it and show you that I'm using it. So important part is using an app intent configuration here. And in that configuration, we're using our app intent timeline provider, which I called color timeline. And in here, as for all timeline providers, there are 3 functions you need to implement: the timeline for configuration in context function, the snapshot for configuration in context function, and the placeholder in context function. Together with this colored timeline app intent timeline provider, I have also created a colored entry, which is just a timeline entry, and that has a date, which is required for timeline entries, and a widget color, which is a custom type that I have defined for my select color intent, which I will show you in a second. But this is basically the color that the user is selecting, and we're then passing into our widget timeline provider here, and through that into the timeline entry and into our colored widget view. So this colored entry, very simple, a date and a widget color, which I will show you in a second. So for our timeline provider, in the placeholder function, I'm just creating a placeholder colored entry for right now with one of my mocked widget colors. For the snapshot, I'm just taking the current date and the color that is configured in our select color intent, which we will have a look at in a second. And then for the timeline, I'm doing the exact same thing. So I'm just grabbing the selected color from our intent, using the current date, and I'm saying we don't need to ever refresh this timeline. I will handle that myself, because in this example, there's no data displayed in the widget. It's just a color, so there's really no reason to ever reload our timeline. It will get automatically reloaded when the user changes the configuration of the widget, or we can manually reload it through widgetcenter.shared.reload timeline in our app or any other place. And then the view is also very simple, takes our colored entry and displays the selected widget color. So let's have a look at our select color intent, and I will go through this one by one because we actually have 3 types defined in this file here. So let's start with the app intent itself, and it's very important that this is not just conforming to the app intent protocol, it actually has to conform to the widget configuration intent protocol, because we want to use this intent for a app intent widget configuration. For these widget configuration intents, there are 2 required attributes, which is the title, which is a localized string resource. In this case, I just called the intent widget accent color, and then a bit of a longer intent description. I just said select widget accent color. Those can be strings, whatever you want them to be, very much depends on your app. Just know that you have to implement a title and a description as static variables on your widget configuration intent. And then I also added a parameter because, of course, why would I want to configure a widget using an intent that has no parameters? So in our case, the parameter, I called it accent color, and that title there is what's being displayed right here. I don't think you can ever see the intent title and description when you're just using it for your widget configuration. But anyway, so this is the accent color parameter, and this thing over here that I can select is my widget color. Widget color is a custom type that I defined. Of course, you could also use built-in types like string, bool, int, and so on, but I wanted to have a custom type here. And instead of trying to conform the SwiftUI color type to this app entity protocol, which is needed to use your own custom types with AppIntents, I just created a widget color. So this widget color is very simple. It has an ID, which is required, and it then has a color, which basically is the translation of widget color into our SwiftUI color that we are then using inside of the actual widget background. There are a few things here that are required. So the identifier is required, the type display representation is required, and the default query is required. The default query is the way that our app can provide options for the user to select from. So I will show you my widget color query in a second, but this is where we got the red, blue, and orange recommendations or selections from. And this is also where I defined which color is the default select or is selected by default when creating this widget. You then also have to implement a display representation, which basically is the string that is displayed right here in the selection menu. And I'm just showing the ID because I'm using ID as a name parameter basically. So I've created some mocked data here. This is absolutely not needed. You can completely get rid of this if you're actually loading these options here from your app, from the network, whatever. I'm just mocking it here because I don't want to implement a network request just for this tutorial. So in the mock data, I just have red, blue, and orange, and there I always added the ID string, which is the one that's shown right here through the display representation. And then the actual SwiftUI color, which is then used inside of the widget background. All right, so the last thing missing is our entity query. And just as a reminder, we're associating that query with our app entity through this default query static variable here, which is required. All right, so the entity queries need to implement 3 functions. Default result, which is basically the entity that is selected by default when the widget is first added. This is optional, but you still have to implement this function. Suggested entities, which is the list of full entities over here. And then there's also entities for identifiers in case this list is longer and the user actually has a search screen to go through everything. Now, this is not part of this example, but you could actually see that in my old video on the old intents framework for WidgetKit. So in here, you just get a list of IDs. This is our entity.id. So in this case, just a string representing the color. So what I'm doing is I'm just filtering my demo data by whether this identifiers array here contains the color. So very simple stuff. But this entity query right here, these 2 functions, or probably even these 3 functions, are where you would do your network request, read data from SwiftData or CoreData or UserDefaults or wherever you're getting your data from. So this is where you can actually load the data that the user can then select to configure your widget. And that is basically already everything. So just to show you, let me also select red here real quick and then go back. Widget will get reloaded automatically, and now it's showing the red color because we're showing the entry.widgetColor.color, which comes from our configuration.accentColor, and the configuration comes from our select color intent. So this is actually very simple setup, and from learning about it to implementing this widget, I needed a maximum of 30 minutes. So this should be very easy to do for yourself. And I think the AppIntents approach here is 1,000 times nicer than the old intent definition file approach.